Hey, Algebra 1, we are at lesson 110. We've been sporadically talking about quadratic equations and the different ways to solve them. One of them most recently was completing the square. By adding a certain fraction to both sides, you suddenly created a square that could be solved or completed, which made it possible to solve for x in that quadratic equation. If you were to, we're going to be solving quadratics again today using another technique, this time what you've maybe seen before and has often been talked about, the quadratic formula. And we'll be using these interactivities supplied by the curriculum again. First thing, let's review what each vocabulary term is. The quadratic formula is number 3. That's what we're going to be using today. It's formed by completing the square of the quadratic equation, which is number 2. If you remember the quadratic equation, if you were to complete the square for that problem, you'd end up with the quadratic formula. They show you how that's done on page 742. Remember, a quadratic means we have x to the power of 2. And if you have x to the power of 2, what does a graph always end up looking like? That would be a parabola. That's about the most I'll be talking about graphs today. I think it's example 3 gives you an example of using a graphing calculator to then estimate the intercepts to find your two solutions. But there's no need to estimate on a graph if you just use the quadratic formula. Lastly, number 1 is an example of standard form for a particular quadratic equation. Standard form means we have ax squared, bx, and c, right? In this case, number 1, which is the a? That's the coefficient of 5, right? You're just matching it up with the quadratic equation formula. And since it's already in standard form, it's easy to do. What's the b? Not 3, but negative 3. And c in this example is positive 1. Anyway, back to the quadratic formula. It can be used to solve any quadratic. For example,
plus 3x is equal to 5. Round the answer to the nearest tenth.
Okay.
Take each step to solve the equation. X squared plus 3x is equal to step 1. Write the equation in standard form. X squared plus 3x minus 5 is equal to 0.
So the equation they gave us had 5 on the right of the equal sign. But remember, our standard form puts 5, which is the c, on the same side of the equal, and then it has to equal 0 on the right then, because we vacated that side of the equal sign. Notice what always happens. If you've got the c on the right of the equals, when you change it to standard form, you change the sign, right? Because you've subtracted it or added it or wherever you needed to do. I think it's important to write the equation in standard form and not just try to do it from your head. That way you don't get that sign mixed and then get the whole problem wrong.
Step 2. Use the quadratic formula. Identify a, b, and c in the equation. A is 1. B is 3, and C is negative 5. Substitute 1 for A, 3 for B, and negative 5 for C.
Sorry if he wasn't loud enough before, but should be now. So using this quadratic formula, all you need to do is know which ones are A, B, and C. You plug them in, and then you use the algebra you're used to end up solving for x, which is already all by itself over there on the left. It's really not that hard, and I might even say fun.
Step 3. Solve for x. Simplify. X is equal to negative 3 plus or minus the square root of 29, all divided by 2. Write as two equations. X is equal to negative 3 plus the square root of 29 divided by 2. Or x is equal to negative 3 minus the square root of 29 divided by 2.
Notice you end up with two solutions.
Simplify.
Because of the plus or minus.
X is approximately equal to negative 3 plus 5 4/10 divided by 2. Or x is approximately equal to negative 3 minus 5 4/10 divided by 2.
Are you done, sir?
X is approximately equal to 2 4/10 divided by 2. Or x is approximately equal to negative 8 4/10 divided by 2.
So if you actually square that ugly number,
X is approximately equal to 1 2/10, or negative 4 2/10.
if you actually square 29 and get that decimal mix number, you can get it all the way down to an approximate 1.2 or negative 4.2. And what you'll find is if this is a word problem and you're asked to solve for something like time, you'll know there's only one answer. Why? Because time can't be measured in a negative, so we can't be talking about the negative. That's on the side of the parabola we won't use. But in this case, we have to list both answers. Again, because there's a plus or minus, there are two possible answers. If you want to solve 7x squared minus 2x equals 8, which numbers would you substitute for a, b, and c in a quadratic formula? And I think this quadratic formula is especially useful when you do have a coefficient on the x squared, which we didn't have up until this example. Now, hopefully my pens are working for me here. Before we answer, what are we always supposed to do? Write it in standard form, which means we have to subtract the 8 on both sides, right? Now we have minus 8 equals 0. See, the first time I did this one, I thought letter A, but no, right? Because the c's positive here, and that's not going to be the case when it moves over, right? So our answer is going to be B. Number 2, which one is one of the solutions? Okay, we don't need both. We're just going to answer for one of them. Notice in this case, they don't actually square out that ugly number. That's why I didn't expect them to do it in the previous example there, but he just kept going. All right, they've already got it in standard form, right? What's the A? A is 1, okay? B is not 7, but negative 7. C, it's already in standard, so it is positive 4. Okay, now, quadratic equation formula is not currently up on the screen, but if you want to find it on page 742, that's what I'm looking along with right now, so I can do this. The quadratic formula says we have to start with a negative b. Since it's already negative 7, it's going to end up being a positive b, or 7. Plus or minus the square root of b squared. Again, b is negative 7, so when you square it, we don't have to worry about the negative anymore. It's just 49. 49 minus 4 AC. A is 1, so I'm not going to bother writing the A, but C is 4. I'm going to write this far. The bottom, 2 times A. Again, A is just 1, so the bottom is just 2. You already may be doing this in your head. 4 times 4 is 16. So 49 minus 16, we've got the square root of 33 under there, under the radical. 7 plus or minus the square root of 33. So it's going to have to be either this one or this one. Notice they've got a negative over here, so I'm guessing it's not that one. Let's find out if we got it right. Letter A is my guess. Bingo. And number 3, solve 2x squared plus 5x minus 3. Again, we have to do step 1, which is write this quadratic in standard form. Okay. Oop. I didn't write it in standard form. I just wrote absent-mindedly what was already there. Standard form means the C now becomes positive, right? Equals nothing. Okay. Now, the A is 2, right? B is 5, positive 5. C right here is 3. Quadratic formula, maybe you've already got memorized. It's kind of fun that way. Negative 5 plus or minus square root of b squared, or 25, minus 4. Again, a is 1. Sorry, a is 2. What am I doing? What am I doing? A is 2 and C is 3. All over 2 times A. Next step, right? We're on step 3 if you want to think of it that way. Negative 5 plus or minus the square root of 25 minus, can you do all this in your head? Oh boy. Oh boy. Sorry about that. I don't know why it's having a hard time with that particular gesture. There you go. 4 times 2 times 3, or 8 times 3, 24. 2 times 2 on the bottom is 4. Okay, so I think we're ready to start going 2 directions here. It's either negative 5 plus the square root of this is going to be 1, isn't it? So, you with me? And that ends up being negative 5 plus 1 is negative 4 over 4, or negative 1. This direction will use the negative 1 over 4, which means negative 6 over 4. And if you find that to a decimal, it comes to negative 1.5, 1.5. Okay, which is our answer? Looks like the 4th and final choice there. That's how you use the quadratic formula to solve quadratic equations. Example 5, by the way, is an object in motion from an initial height s, 70 meters. Luis tosses a ball up at a velocity starting at v, 5 meters per second. Use the equation, and then they give you an equation to plug those into. Okay? So you put the v that they just gave you in the b spot, and then you put the s that they gave you, which is 70, in for what really is the c spot. Now you've got set up standard form for a quadratic formula. And as I kind of previewed earlier, when you get down to the approximate answers, you rule out the negative, because that's the x-intercept on the left of the axis, which is not going to pertain because it's starting at the y-axis. So I can show you what I mean. If you get a negative answer, that's referring to this x-intercept, right? We can't measure time, which is what the x-axis is measuring. We can't measure that in negative. So this cannot be the answer. And you end up just using the positive, right? Which is telling you how many increments of time have passed until it reaches that spot, until it hits the ground. Okay? So letter F in the examples is your chance to try that. You'll have to use the equation that they give you in lesson 5, or sorry, example 5. So use the equation they created in example 5. Use that for lesson practice F. Okay? Besides that, I'd like you to do B, C, and E. So B, C, E, and then we said F, please. So 4 there for me, please. Okay. Thank you for listening and learning.